Hey, it's been a long time. Actually, it's been a couple of days. But I've been so busy, busy for you know, my works. And today I have a little bit of time, so I solved another leetcode problem. It's my 52nd problem, and its number is 45, and its title is Jump Game Second. It's actually a medium level of difficulty, but I think this question is really good, to have interview. So let's start. It's like it gives us an array of non-negative integers. Let's call this nums, such as 2, 3, 1, 1, 4. Okay, and each element represents that how we can jump, how many steps we can jump. Like if we have 2, this means we can jump over here, but it is not necessary. You can just choose, between 1 or 2. This represents the maximum number of steps. So our goal is to reach the last index in the minimum number of jumps. So, and the output should be the count of jumps to reach the last index. For this example, I'm going to choose jump over here, and then I'm going to jump 3 steps over here to reach the last index. So answer is 2. This means we needed only 2 jumps to get to the last. So my idea is very simple. Okay, I'm gonna rewrite this. Okay, we have a idx index represent where we are now, and I'm going to simulate for every element. So we have 2, so that means I'm gonna simulate with those 2 numbers. If I have 3, my simulation area must be until here, but I have 2 now. So just take a look at this. Let's assume that we have another subarray. Let's have another index that indicates the rest of elements. Let's call this just E. And I'm going to calculate this. E minus index represents how many steps. How many steps do we how many steps I'm going to jump to reach this element, n plus the number of itself, So if I choose one steps here, I'm going to get four steps in next time, you know. And on what if I choose two steps here, I can reach, I can jump, I can reach two here. I can reach only three steps, two steps next. So it's the best idea to choose this element here. So I'm going to iterate the subarrays until I find the most and biggest steps for the next time. That's it. So my pseudocode, it doesn't. I don't think I need a pseudocode because it's really simple. Yeah, that's it. Just this problem is very clear to make algorithm because it has a answer in this question itself. And I made my code here, and this has this results in faster than 100% of the other Python codes. Its runtime is near 20 milliseconds. I think this works well. That's it for today. Thank you for listening.